Okay. Cool. Let me just get the test.
All right, 1 and 2, easy. 3 from the book. From what I understand, true population is just the regular P.
Yeah, that's what I was thinking too.
Okay, for 4, requirements for constructing a confidence interval. I was thinking true, but
Yeah, because I know for one of them, because the next one is hypothesis test, and I think that one is if n is greater than 30. I don't know. I think they're both true, just because we have those like ranges. Yeah, or that the p times n is greater than 10.
Yep.
Type thing. So.
Cool. All right, so we gotta find the P hat.
Okay, so that formula is just x divided by n. So the sample size divided by, or the sample size divided by the sample population.
So it would be 45 divided by 60, wouldn't it?
Yeah.
So 0.75.
I mean, it says around to 3 decimal places, so that kind of threw me off.
I mean, like, we've done that before. We haven't had 3, and we were still fine.
Yeah.
I mean, like,
We did the other way. 60 divided by 45, we have 1.33 repeating.
Yeah, I would say go with this one. Okay. Because it's focusing on the 45 defendants, and then they had a random sample of 60.
Sure. Determine a margin of error for this 95% confidence interval. Hey, we know how to do that now.
Yeah, so the next ones are asking for lower and upper. So let's find that.
Yeah, so 8 and 9 are lower and upper bound. Did you go to the little test review thing?
For the exam?
For like the missed questions?
Yeah.
It was just like so crazy how it felt like the questions just look so similar.
Yeah, I know. I mean, when she explained it, I was like, oh, duh, that's why I got it wrong. But taking the test, it was like you can, I don't know.
There's no way you would find the difference.
Yeah. Okay, so for the lower bound, we do p hat minus so the confidence interval, so it's asking for what? 95, right?
Yeah.
Okay, so that's 1.95.
Is it 95 or 96?
I think it's 95. That's what I have written down.
Okay, that's right, true. I was going off memory.
No, it's 9. No, yeah, it's 96.
96, yeah.
Yeah. And then square root.
Fill it all in.
So times the square root of p hat parentheses 1 minus p hat, and then that divided by n. So let's see.
Plus.
That would be
divided by, what's n again? 45? Or 60?
Okay, so what'd you guys get?
I hope I calculated this right. I have 0.757.
For, did you plus or minus?
For plus.
Okay, so I did minus. Let me try. Okay, so for plus I got 0.85. 5.
Okay. Yeah, I just redid it, and I
Let-
accidentally put my parentheses in the wrong spot. So for minus, I have 0.640.
Let me see. Yeah, 0.640.
And then upper 0.85. Oh, 0.860, right?
Yeah, because we'd round up both of those.
That makes sense.
Okay.
Now we get to find the margin.
So now
of
we just
error.
minus them, right?
Yeah, minus 7 and then divide by 2.
So I have 0.10 or 0.110.
Yeah, that's what I got too.
If you increase the sample size from 60 to 80, what do you expect to happen with the confidence interval? I don't want to say.
So I wrote down, yeah, from the video, it's asking if the sample size increases.
Yeah.
Okay, so if the sample size increases, then the interval decreases.
Cool.
Okay. Yep. Very cool.
To conduct a hypothesis test for one portion, two requirements must be met. Suppose that P equals 1/2. What is the smallest N can be, and both requirements be met? Oh, what did
this
we
is what
do?
we did
The
with that other
TA
one.
helped us.
Yeah, so I think we did 40, right? Because we had to do the highest one that, or the smallest one that both could be met.
Yeah, but that was with 1/4, right?
Oh yeah,
This is 1/2. So
all right. Yeah, so we plug it in the requirement formula thing.
okay. So N times P.
So N 50 times 45.
One minus.
Okay. N times 1 minus 45. That. Go back to 4.
Oh, I think it would be 20.
Oh, makes sense.
That would, because it's 1/2 40.
Mm-hmm.
Yep.
Okay. To conduct a hypothesis test for one portion, two requirements must be met. Okay, so now we just do it with 1/10.
Mm-hmm.
N's gonna be way small.
So
So we
Well, so I just did like the 0.1 because that's 1/10 divided by, or 10 divided by 0.1, and that's 100. And then for the other one, it'd be 1 minus 0.1 is 0.9, so 10 divided by 0.9 would be 11.11. So for both requirements, I think it would be 100 because we need both of them to.
okay, that makes
Okay.
sense. The conditions for conducting a hypothesis test are satisfied.
I would say so.
Yeah.
P hat would be
Oh, it wants us to find
So
it.
yeah, 38 divided by 80. 0.7 or 0.475.
right. That's what I got.
Okay.
Guys, where was this math a couple weeks ago when we were struggling?
Test statistic.
Mhm. So that, I think, I don't know if it gave it in the textbook.
It's so much easier to find out on SPSS.
I know. But I mean, I have the big formula written down.
The test is statistic.
Okay, so it's value minus mean divided by
By
standard deviation, right?
So P hat
Minus P.
which would be 38.
And remember, we have to recalculate out always like.
No, because our p hat is 0.475
Okay, and then our P.
Is
0.6.
P is 0.6.
Okay, and then we do the standard deviation again.
Divided by square root of P.
Yes.
Parentheses 1 minus P divided by N.
Mhm.
I always put my parentheses in the wrong places, I feel like.
I know.
What's our N again?
It is 80.
Yeah.
Okay, I have a very large number.
Okay. I got negative 2.282.
You probably didn't see.
That's what I got. But I can, well, let's see. Let me do it again.
You should do the one with near parentheses at the top. Like, did you do this? You want a parentheses to square root.
Oh, dang. So I did it again, and now I got, maybe I did it wrong. I don't know. I got negative 2.239. So let me try it one more time.
Yeah, I'm doing the same thing.
Minus 0.6 divided by square root 475 minus 0.475 divided by 80. Okay, so yeah, so I got negative 2.239.
Okay.
Hold on. What was P again? What was P?
P is 0.6. Except, yeah, you got to do P. You have it as 1.
Or what is it supposed to be?
0.6.
N was again which number?
80.
What are we doing wrong?
So what I first do is the p hat minus p, and then I do an equal sign, and then I that by the square root.
Got it.
So less parentheses.
That makes
That
sense.
makes sense. We've plugged it all in, so.
Okay.
Okay, 16. What's the p-value for this test?
Yeah, so that don't we just plug the test statistic into the applet?
Oh, yeah,
Maybe?
it's totally. Oh, or would it just be 0.6? Maybe not.
I don't know.
Using the normal applet, you can find the p-value. This is a two-tailed test. Make sure both tails are shaded, and then enter the z-score.
Z-score again
Okay.
was
When the test.
Negative 2.239. Oh, wait. Yeah, that's our test statistic. So we have to find the z-score?
right.
Oh, no, that was our z-score. Yeah, we're good.
It's our z-score. So it'd be.
I've got 0.025.
Okay, yeah,
Cool.
that's what I have.
17, what's the decision for the test? So
So-
with
P-value is less.
So if it's less, then we reject.
Which following best summarizes the conclusion of this test? Oh, this is my worst
These were the ones
nightmare
that
after
killed
taking the
me.
test.
Really?
So reject
So if we reject,
insufficient.
then it's sufficient. Yeah.
Sufficient.
Yeah, it's sufficient. So then we just need to look at the problem and see what they're testing. If they're testing that it won't decrease or that it is decreasing.
I'll read it. For the water quality study in the reading, about 60% water indicators have historically been associated with good health. Researchers suspect the water quality in the area has decreased.
So it'd be the last one.
Yeah.
Okay, I'll turn it in.
Okay.
This might be record timing for us.
Well, I hope it's right.
Oh, we missed two.
We missed 2. We missed number 16, and we missed 15 and 16.
15 and 16.
Mm.
So I'm wondering if you
Okay.
put them all in at once and you don't enter anything.
Because I got the same one.
Yeah, let's see.
Okay, someone's gonna have to catch me up.
Yeah, let me try to. Yeah, I'll work on it.
Okay, I'm gonna catch myself up.
Okay.
This is lesson 17.
But we got 14 right, and so we know our P hat is correct.
Hold on. 14?
Yeah.
Yeah, that one's right.
Okay, awesome.
I would just clear it instead of so your eyes don't get faded out.
Oh, I see what I did wrong. I put in P hat instead of our regular P in the formula when we did it before.
Oh, okay.
So I got 0.451.
For the test statistic?
Yeah.
Okay. Because I did it and I got negative 2.28. 282.
So negative 2.282.
Mm-hmm.
Let me throw that through the applet and see where we're at. So that means we'd be 0.023.
Okay.
You want me to? I can try to submit it with those two.
Okay, which ones did we miss? What was 15? What did we just?
I can catch up, Sydney.
I just like pulled it up and I'm just like transferring
And
all
then
my.
16 would be negative or 0.023. 17's reject, and then the last one. Okay, I'll submit it and see where we're at.
Okay.
Moment of truth.
We missed one.
How?
How in the world? We missed our p-value.
So we got 15 right, but 16 is wrong. Oh.
Okay, so how do we find the p-value? Let me see.
Because the book told me to find the p-value, just plug it in the applet, make sure you shade both sides. Shade both sides first.
I did.
Did we round wrong? 0.023 is what it should be. Yeah. That's weird.
That's way weird. Can you pull up the book? Sorry, I closed my not one. Yeah, keep going. Enter the z-score. The combined area.
We wouldn't divide
Type
it by
in
2. It
Type
made
in
it.
p-value in your searches.
Oh, yeah. What kind of problem do we have?
2.
If it's two-tailed or not.
Yeah, let's see.
It is, I think.
Yeah, well, I can try it because I think that's the only other.
Option.
Yeah. Okay, if it's one-sided, then it's just a greater than or less than sign.
Well, if
So we just gotta divide by 2.
So we just divide the negative 2.82 by 2.
No, we divide the p by 2.
Oh. What was the
0.012. Okay, and then I'll submit it and see.
Sounds good.
Okay, so yeah, 16 is right.
Sweet. So
We
we
got 'em all.
do you want me to catch you up?
No, because I can just submit that one
Oh. That
score.
Sweet. So we're done.
what do we have for 16 again?
0.012.
Sweet. Okay, we'll see you on Tuesday.
Awesome. Thanks, Jensen.
Good night.
See ya.
See ya.